Have you ever wondered just how vast our solar system really is? Imagine riding on a beam of light, the fastest thing in the universe. Even then, it would take you more than 5 hours just to travel from the sun to the edge of the solar system. That's not just distance. That's immensity, beyond anything we can experience on Earth. Our solar system isn't just a family of planets orbiting a star. It's a sprawling, dynamic system, home to gas giants, rocky worlds, icy moons, mysterious dwarf planets, and an invisible edge that stretches across billions of kilometers. Today we're taking a journey from the blazing heart of the sun to the frozen outer limits of space, visiting every major world along the way. We'll uncover their secrets, their stories, and their place in the vast cosmic dance. This is more than astronomy. This is a voyage of scale, of awe, and of perspective. The sun, the heart of the solar system. At the very center of it all lies the sun, the furnace that makes life on Earth possible and keeps the entire solar system bound together. This massive ball of glowing hydrogen and helium contains over 99.8% of all the mass in the solar system. Everything else, planets, moons, comets, and asteroids combined, would barely make up a fraction in comparison. With a diameter of 1.4 million kilometers, the sun could fit more than 1 million Earths inside it. It burns at an internal temperature of 15 million degrees Celsius, constantly fusing hydrogen into helium and unleashing a torrent of energy into the void. This energy, traveling outward as light and heat, takes just over 8 minutes to reach Earth. But that same light could take thousands of years to travel from the sun's core to its surface before it even begins its journey through space. The sun's gravitational pull extends far beyond Pluto, shaping the orbits of everything within the solar system. Without it, the planets would fly off into space. But with it, a delicate cosmic balance is maintained, with each planet spinning and dancing in harmony around this central star. It's not just the giver of light, warmth, and life. The sun is the reason the solar system exists at all. Mercury, the closest planet to the sun. First, on our journey outward from the sun, is Mercury, a scorched, battered world that races through space faster than any other planet. It's the smallest of the 8 major planets, barely larger than our moon, yet it orbits the sun at breakneck speed, completing a full revolution every 88 Earth days. Located just 58 million kilometers from the sun, Mercury is constantly blasted with intense solar radiation. With no thick atmosphere to protect it, the planet's surface endures dramatic temperature shifts, scorching up to 430 degrees Celsius during the day and plunging to 180 degrees at night. It's a world of fire and ice, depending entirely on whether the sun is overhead. Mercury's surface is ancient and cratered, telling the story of a planet that has endured billions of years of impacts. With no plate tectonics or weather to erode its features, every scar and ridge remains frozen in time. You're essentially looking at the same terrain that existed over 3 billion years ago. Despite its proximity to the sun, Mercury isn't the hottest planet. That title goes to Venus. But it is the fastest, the most extreme in day-night contrast, and the most elusive to observe from Earth. It has no moons, no rings, and almost no atmosphere, just a thin layer of exosphere made of oxygen, sodium, and hydrogen. But what Mercury lacks in complexity, it makes up for in mystery. Recent missions like NASA's Messenger and the European-Japanese Bepi Colombo have begun to peel back its secrets from signs of volcanic activity to possible water ice hidden in permanently shadowed craters near its poles. Mercury may be small, but it's no less dramatic. It's a fitting start to our planetary odyssey, a silent ancient world that clings to the sun like a moth to a flame. Venus, the hellish twin. Next in line from the sun is Venus, often called Earth's twin because of its similar size and composition. But make no mistake, this twin lives in hell. Venus is roughly the same size as Earth, with a diameter just 650 kilometers smaller. But that's where the similarities end. Beneath its thick yellowish clouds lies the most hostile surface of any planet in the solar system. Temperatures on Venus soar to nearly 470 degrees, hot enough to melt lead. That's hotter than Mercury, even though Venus is farther from the sun. Because Venus is wrapped in a dense atmosphere of carbon dioxide, creating a runaway greenhouse effect. The heat is trapped and recycled, cooking the planet from the inside out. The atmospheric pressure is another nightmare, 92 times greater than Earth's equivalent to being nearly a kilometer under the ocean. And the clouds. They're made of sulfuric acid swirling in hurricane-like storms that circle the planet at speeds of over 300 km/h. And then there's the rotation. Venus spins in the opposite direction of most other planets, and incredibly slowly. One day on Venus is longer than its year. That means the sun would rise in the west and set in the east, if you could see through the choking clouds. Despite these harsh conditions, Venus has fascinated astronomers for centuries. Early skywatchers saw it as a beautiful morning and evening star glowing brightly in the sky. But spacecraft like the Soviet Venera landers and NASA's Magellan orbiter revealed the terrifying truth beneath the veil. The surface is a rocky wasteland with vast plains, volcanoes, and mountains. Some scientists even believe Venus once had oceans and a more temperate climate billions of years ago, before a dramatic climatic shift turned it into the inferno we see today. Venus is more than just a warning about greenhouse gases. It's a mirror showing us what could have been and what might still be if balance is lost. Earth, the living planet, third from the sun. We arrive at the only planet we know that harbors life Earth. It's easy to forget how extraordinary our world is. Among the hundreds of billions of planets that likely exist in our galaxy, Earth is the only one that we're certain has oceans of liquid water, a breathable atmosphere, and a vibrant web of life stretching from the deepest trenches to the highest peaks. Our planet orbits the sun at a comfortable distance of about 150 million kilometers, the Goldilocks zone, where temperatures are just right for water to remain in its liquid state. This precious liquid covers over 70% of the Earth's surface, regulating climate and sustaining ecosystems. The atmosphere, made primarily of nitrogen and oxygen, is thick enough to protect us from harmful solar radiation, but thin enough to let in warmth and light. It shields us from meteoroids, burns them into harmless streaks, and maintains a balance that keeps the biosphere alive. One of Earth's most remarkable features is its magnetic field, generated by the churning molten iron in its core. This magnetic shield deflects solar winds and cosmic rays, preventing the slow erosion of our atmosphere like we see on Mars. But Earth, doesn't dance alone. Our moon, large relative to our planet, plays a crucial role in stabilizing Earth's tilt, giving us seasons, tides, and long-term climate stability. It's believed that a colossal impact in Earth's early history led to the moon's formation, a violent beginning that gave rise to a gentle companion. Earth isn't just our home, it's an oasis floating in the vast emptiness of space, teeming with forests, oceans, cities, clouds, animals, and us. It's the only place so far where the universe has looked back at itself and wondered. As we move outward, the worlds we visit become stranger and less familiar. But here for a moment, we pause not to marvel at the alien, but to appreciate the miracle we've always known. Mars, the second hope. Beyond Earth lies Mars, a world that has captivated human imagination for centuries. The red planet. Dry, desolate, yet strangely familiar. Mars is roughly half the size of Earth, with a thin atmosphere composed mostly of carbon dioxide. Its surface is barren and dusty, painted in shades of rusty red from iron oxide, the same material that gives blood its color. Despite its lifeless appearance, Mars is the most Earth-like of all the other planets, and perhaps the one with the greatest potential for future human settlement. Mars is a planet of extremes. It's home to Olympus Mons, the tallest volcano in the solar system, nearly 3 times the height of Mount Everest. Nearby lies Valles Marineris, a canyon system that stretches over 4,000 kilometers, as long as the United States is wide. Unlike Venus or Mercury, Mars has seasons, polar ice caps, and weather patterns, albeit weaker and more erratic than Earth's. Winds sweep across its surface, carving dunes and lifting massive dust storms that can engulf the entire planet for weeks. Perhaps most intriguing of all is the evidence that Mars once had water, and lots of it. Ancient river valleys, lake beds, and minerals that only form in water tell the story of a wetter past. Even today, water ice is locked beneath its surface, and some scientists believe that briny liquid water might still exist deep underground. Mars has no global magnetic field and only a fragile atmosphere, making its surface vulnerable to solar radiation. But that hasn't stopped humanity from reaching for it. Robotic explorers like Spirit Opportunity, Curiosity, Perseverance, and the Ingenuity helicopter have rolled, drilled, and flown across its plains, collecting data and sending back breathtaking images. Mars is not just a destination in science fiction anymore. With planned missions by NASA, SpaceX, and international agencies, the dream of walking on Mars may soon become reality. To stand on another planet, to gaze up at its pale pink sky, and down at the cracked soil beneath your boots, that vision drives innovation, unites nations, and reminds us that exploration is written in our DNA. Jupiter, the giant of giants. Now, we cross the asteroid belt and arrive at Jupiter, the king of the planets, the colossus of our solar system. Everything about Jupiter is massive, mysterious, and majestic. With a diameter of 143,000 kilometers, Jupiter is more than 11 times wider than Earth. If it were hollow, you could fit over 1/300 Earths inside. But it's not just its size that commands attention. It's what lies beneath the swirling clouds that scientists still struggle to understand. Jupiter is a gas giant composed mostly of hydrogen and helium similar to the Sun. It has no solid surface, just layers of increasingly dense atmosphere, eventually becoming a strange metallic liquid deep inside. At its heart, there may be a rocky core, but we're not entirely sure. What we do know is that Jupiter is a planet of storms. The most famous of these is the Great Red Spot, a colossal storm larger than Earth, raging for over 300 years. It's a planet where the winds blow at over 600 km/h, where lightning flashes in hydrogen storms, and where gravity crushes anything that dares to descend. Jupiter's immense mass gives it the strongest magnetic field of any planet in the solar system, 14 times stronger than Earth's. This field traps charged particles in deadly radiation belts, forming an invisible shield that stretches millions of kilometers into space. But Jupiter isn't alone. It's orbited by at least 95 known moons, a miniature solar system in its own right. Among them are some of the most fascinating worlds in the solar system. Ganymede, the largest moon in the entire solar system, even bigger than Mercury. Europa, a frozen moon with a subsurface ocean that could harbor life. Io, the most volcanically active body in the solar system. And Callisto, ancient scarred and still hiding secrets beneath its crust. Without Jupiter, the solar system might have turned out very differently. Its massive gravity helps protect the inner planets by deflecting comets and asteroids. It's both guardian and giant, balancing chaos and order. To look at Jupiter is to stare into a planet-sized mystery. We've sent spacecraft like Galileo and Juno to orbit and study it, yet Jupiter continues to astonish us. It is not just a world, but a force of nature. Saturn, the Lord of the Rings. If Jupiter is the king, then Saturn is the jewel of the solar system. With its breathtaking rings and soft golden hue, Saturn has inspired awe for centuries, even in ancient times, when early astronomers could only see its soft glow with the naked eye. Like Jupiter, Saturn is a gas giant made mostly of hydrogen and helium. But it's lighter. In fact, it's so low in density that it could float in water if you could find an ocean big enough. With a diameter of about 120,000 kilometers, Saturn is the second largest planet in our solar system. But it's not its size that steals our breath. It's the rings, delicate, expansive, and hauntingly beautiful. Saturn's ring system spans more than 280,000 kilometers wider than the distance from Earth to the Moon. Yet they're astonishingly thin, often just tens of meters thick. Composed of billions of particles of ice and rock, from tiny grains to massive chunks, they form distinct bands, each with their own dynamics. But where did the rings come from? Were they once a shattered moon, or remnants of the early solar system that never formed into something larger? We still don't know for certain. What we do know is that they are slowly fading, being pulled back into Saturn by gravity in what scientists call ring rain. Someday, millions of years from now, the rings may vanish completely. Saturn, too, has its own family. At least 145 known moons, each unique. The most famous is Titan, larger than Mercury, wrapped in a thick atmosphere and dotted with lakes and rivers of liquid methane and ethane. It's one of the most Earth-like landscapes we've seen, just colder and far more alien. Then there's Enceladus, a tiny moon, just 500 kilometers across, but one of the most promising places to search for life. Beneath its icy shell lies a liquid ocean, and geysers of water vapor erupt into space, hinting at hydrothermal vents on the ocean floor. Thanks to missions like Cassini, which orbited Saturn for over 13 years, we now see this world not as distant and silent, but as dynamic and ever-changing. A realm of wind rings and hidden oceans. Saturn is a planet that reminds us beauty exists even in the coldest corners of the cosmos, and that mystery can wear a crown of ice and light. Uranus, the sideways world. Now, we drift farther into the cold, shadowed outskirts of the solar system and arrive at Uranus, the planet that broke the rules. At first glance, Uranus appears calm, a pale cyan orb spinning slowly in the dark. But beneath that icy blue facade lies one of the strangest and most enigmatic worlds we've discovered. Uranus is unique in one major way: it spins on its side. Its axis is tilted more than 98 degrees, essentially rolling along its orbit like a ball, rather than spinning like a top. Scientists believe a massive collision early in its history knocked the planet sideways, altering its orientation permanently. This strange tilt causes extreme seasonal changes. Each pole gets 42 years of continuous sunlight, followed by 42 years of darkness. Imagine living in a place where the sun never sets for 4 decades, only to disappear for the next 40. Like Jupiter and Saturn, Uranus is a gas giant, or more precisely, an ice giant. Its atmosphere contains more water, ammonia, and methane ices. It's that methane that gives Uranus its signature bluish tint by absorbing red wavelengths and reflecting blue. Uranus is massive, over 14 times the mass of Earth, but it has a very cold and quiet atmosphere. In fact, it's the coldest planet in the solar system, with temperatures dropping to 224 degrees Celsius, colder than even distant Neptune. No massive storms have been spotted like those on Jupiter or Saturn, though some faint cloud activity has been detected. It also has a set of rings, faint and narrow, and at least 27 known moons, many named after characters from the works of Shakespeare and Alexander Pope. Moons like Miranda, with its bizarre fractured surface, or Ariel and Titania, which may have underground oceans. Despite its size, Uranus remains one of the least explored planets. Only one spacecraft, Voyager 2, has ever visited, flying by in 1986. But new missions are being proposed, and there's much left to uncover. Uranus is a quiet giant rotating in solitude, hiding its secrets in blue haze and tilted silence. A world that defies expectations and reminds us that the universe doesn't always follow our rules. Neptune, the windy ice giant. At the edge of the classical solar system, 4.5 billion kilometers from the Sun, lies Neptune, a deep blue world of storms, ice, and wind. Neptune is the 8th and farthest known planet from the Sun. It's the sister planet of Uranus, another ice giant, but more vibrant, more dynamic, and far more mysterious. It was the first planet to be discovered not by sight, but by mathematics. In the mid-1800s, astronomers noticed Uranus wasn't moving as predicted. They suspected an unseen planet was tugging on it. Calculations led them to Neptune, a triumph of intellect before anyone had seen it. with a telescope. Neptune is nearly 4 times wider than Earth, and its atmosphere is made mostly of hydrogen, helium, and methane, the methane giving it that rich blue hue. But where Uranus is placid, Neptune is fierce. It's home to the fastest winds in the solar system, reaching up to 100 kilometers per hour. These winds fuel massive storms that rage across the planet, including the once visible Great Dark Spot, which was observed by Voyager 2 in 1989, but later disappeared, only to be replaced by new storms elsewhere. Temperatures plunged to near absolute zero, around 218 degrees. Yet despite being so far from the Sun, Neptune radiates more internal heat than Uranus, and we still don't fully understand why. It too has rings dark thin and clumpy and 14 known moons. The largest of these is Triton, a strange icy world that orbits Neptune in the opposite direction of the planet's rotation. This retrograde motion suggests Triton wasn't born there, but was likely a captured object, perhaps once a dwarf planet of its own. Triton has geysers and icy crust, and possibly a subsurface ocean, and is considered one of the most likely places in the outer solar system to host microbial life. But time is running out. Triton's orbit is slowly decaying, and one day it may be torn apart by Neptune's gravity, forming a spectacular ring system in its final moments. Neptune stands as the last great planet, the sentinel of our planetary family, watching the boundary where the solar system fades into the void. Pluto and the outer solar system, the final frontier, beyond Neptune. The solar system does not end. It only becomes stranger. Here, in the frozen reaches of space, lies a realm populated by dwarf planets, icy bodies, and ancient relics from the solar system's formation. And leading this frontier is Pluto, once considered the 9th planet, now reclassified, but no less fascinating. Pluto orbits at an average distance of nearly 6 billion kilometers from the Sun, but its path is far from circular. Sometimes it's closer than Neptune. It takes 248 Earth years for Pluto to complete a single orbit, meaning it hasn't even made one full trip around the Sun since it was discovered in 1930. It's tiny, only about 2/3 the size of our Moon, but rich in geology. Thanks to NASA's New Horizons mission, which flew by in 2015, we now know that Pluto is far more dynamic than we ever imagined. Its surface is a patchwork of nitrogen plains, towering ice mountains, and possible cryovolcanoes. Volcanoes that erupt ice instead of lava. The heart-shaped region known as Tombaugh Regio reflects a youthful surface with few craters, suggesting recent geological activity. Even more surprising, Pluto may have a subsurface ocean kept liquid by internal heat, and possibly containing the ingredients for life. Pluto also has few known moons, the largest being Charon, half its size, forming a binary system where both bodies orbit a point in space between them. Their cosmic dance is both elegant and haunting, echoing in the silent dark. But Pluto is just one member of a much larger family. It resides in the Kuiper Belt, a vast region of icy bodies dwarf planets like Eris Haumea and Makemake and countless comets. These objects are time capsules from the solar system's birth, preserved in cold storage for billions of years. Farther still lies the hypothetical Oort Cloud, a distant shell of icy fragments that may extend up to 100,000 AU from the Sun. It is the farthest edge of our solar system where gravity loosens its grip and interstellar space begins. Out here, distance becomes almost meaningless. Light from the Sun takes hours, even days to reach these regions. Yet, they remain part of our cosmic home quiet, cold and ancient. The outer solar system is not an afterthought. It is a boundary, a mystery, and perhaps a gateway to the stars. So, how big is the solar system? It is vast beyond comprehension. A place where distances are measured not in kilometers, but in light. Where a signal from Earth takes hours to reach its outermost edge. A place where planets swirl in orderly chaos moons, hide oceans beneath ice, and lonely objects drift for billions of years in silent orbit. From the Sun's blazing core to the ghostly outer shell of the Oort Cloud, the solar system stretches across a space so large that even light, the fastest thing in the universe, takes more than five hours to cross it. And yet, for all its size and grandeur, this is still just one solar system orbiting an average star in one arm of a spiral galaxy. A galaxy among hundreds of billions in the known universe. But here's the most humbling thought of all the places we've seen, all the worlds we've mapped and imagined. Only one has oceans, trees, cities, laughter, and life: Earth. In the search for distant wonders, we must never forget the beauty and fragility of our own small blue world, suspended in the darkness, quietly spinning uniquely alive. The solar system isn't just a collection of rocks and gases. It is our neighborhood in the cosmos, our cradle of origin, and perhaps one day, our stepping stone to the stars. This is home. This is the solar system.